Hello, everyone. In the last lesson, we introduced the method of coordinate system establishment using the one surface, two pins positioning method. This method is the most commonly used positioning technique for box-type parts processing. The end face used as the primary reference surface is typically the assembly reference surface. The reference is coincident, the positioning is reliable, and it meets processing requirements. In today's lesson, we will continue using the engine block as an example to learn the technique of adding array features. Due to the complex shape of the engine block, in this task, we will make use of features like array, construction of piercing points, and composite position tolerance evaluation. Now, let's begin our detailed exploration. Through this lesson, I hope you will master how to quickly generate measurement instructions for multiple similar features using the array function in measurement software, and accurately set array parameters, such as spacing, quantity, etc. Next, let's learn about automatic measurement of features. Start automatic feature measurement. As shown in the diagram, the measurement sequence is generally based on the distribution of features on each surface. It follows a left-to-right or top-to-bottom order, with priority given to processing logic and measurement efficiency. First, measure the features on the y-negative normal plane. The reference plane A has already been measured, so it will not be measured again here. Next, we need to measure cylinder 1 to cylinder 8, which involve 804 optical reference holes. Use probe A90B180 and apply the automatic cylinder command. Measure the 8 optical reference holes at their respective positions, with about 2 layers of points. Each layer should have 3 to 5 points. Then, measure cylinder holes 9 and 10. These are 204.5 optical reference holes. Again, use probe A90B180 and apply the automatic cylinder command to measure them. Next, measure the features on the y-positive plane. There are 4012 optical reference holes that need to be measured. Use probe A90B0. After measuring hole 11 with the automatic cylinder command, apply the array method to generate measurement instructions for the other 3 holes. Next, measure the oblique hole piercing point 1. First, measure optical reference hole 15 and end face 1. Then construct the piercing feature point. Finally, measure cylinder holes 16 to 18. These are 305 optical reference holes. Use probe A90B90 and apply the automatic cylinder command to measure the 3 optical reference holes at their corresponding positions. Next, let's look at the actual operation. In program mode, select Automatic Cylinder, set the number of points per layer to 5. Leave the depth and end depth unchanged by default, and choose 3 layers. Click Create, and rename it to CYL1. At this point, CYL1 to CYL8 have been created. Then, for cylinder 9 and cylinder 10, change the probe angle to A90B0, measure cylinder 11, and increase the end depth a little. Click Create. Select cylinder 11, right-click and choose Copy, then click Edit. And in the array settings, set the z-axis to 25, the number of repetitions to 3, and click OK. Then, click Edit Array Paste, and you will get cylinder 12, cylinder 13, and cylinder 14. Now, for piercing point 1. First select the probe angle A90B, 60, and click OK. Then, in program mode, click Automatic Cylinder, and measure cylinder 15. Set the end depth to 2 mm, click Create, and Close. Next, collect 5 points on plane 1, and rename it to PLN1, then click OK. Next, click Insert, Feature, Construct, Point. Select cylinder 15 and plane 1, choose Penetration Method, then click Create and Close, and rename it to PNT1. Finally, change the probe to A90B90 and click OK. Then sequentially collect points on cylinders 16 to 18, click Create, Create, and Create, then Close. At this point, The 6 features related to the dimensions have been collected. Next, let's look at the actual effect of the automatic measurement. Finally, let's summarize this lesson. In this lesson, we learned how to use the array function to quickly generate measurement instructions for multiple similar features, and how to construct feature points to create piercing points. These skills are extremely useful in the measurement of complex parts such as engine cylinders. They can help improve both measurement efficiency and accuracy. I hope everyone can apply these skills in real-world scenarios and continue to improve your measurement proficiency. Finally, please reflect on this lesson and complete the following exercises to consolidate the knowledge you learned today and deepen your understanding. This lesson ends here. See you in the next class.